Good afternoon, everyone. My name is Justin Johnson. Today I'll be presenting the scenario for Universal Flowers Racing, which is a global race organizer with a goal of funding charities through racing events. Their current landscape is filled with disparate regional databases, which they want to replace in a phased rollout with a Salesforce solution that is able to adapt to scale, including large data volumes, deal with the peaks of guest user accessing and refreshing for the tracking of racers, and the resolution of some governance complexity and their fragmented teams. They plan to roll out in 6 months within the United States or within North America in a phased rollout, and then are projecting to roll out in the European Union in a year. So the risks identified, and I'll start with the governance risks, starting with control, where they have currently no development or deployment guardrails. Developers are frequently deploying directly to production. So what we'll do is implement a COE that will provision a CI/CD pipeline that will then enforce a standalone process for deployments. And then there will be a change advisory board for the deployments to production so that there's a complete visibility and alignment with what is going into production. So there's no shadow compliance, as well as another risks with the Universal Flowers Racing operating within the European Union. We'll need to embed the Romanian team for EU compliance. We'll enable Shield for the Privacy Center as well. Another compliance risk here is, of course, the fact that we are not that the governance would lock them into a single design with a centralized COE. So what we'll need to do is implement a federated COE model for regional flexibility, and then a centralized COE that operates for the global best practices and shared code. And then that will all fall under a steering committee that will apply a strategic vision for the solution itself. Another risk is the timeline risk that includes the time constraint of the 6-month pilot. This is something that is potentially won't be able to scale with their current distributed teams and scale, and also to meet the velocity, they will need to have a mature organization. So the solution here is a racing matrix that delegates authority to specific teams or individuals for approval authority, and then also delegated decision authority as backups in case there are no potential blockers for the development to meet the 6-month timeline constraint. Some of the assumptions I made is that Salesforce will be the system of record for the race operations. The tracker database will be the system of record for racer tracking via pubs model that will integrate with the ESB, and I'll describe that later on. Okta will be the identity layer that will feed the internal identities to Active Directory and external identities to the current LDAP. DashPay will act as a payment gateway. The registry will act as a system record for racer history, and there will be a static SPA, single page application of a CDN for guest tracking, for unauthenticated user tracking of racers. And the ESB will own the RFID that will be private, and then the tracker IDs will be used for the public searching of racers, and that will be mapped directly within the ESB store. Moving on now to the actors. We'll start with the internal. We have the territory race coordinators and the territory route leader. The territory race coordinator operates above the route leader in the role hierarchy. Both receive Sales Cloud license for access to opportunities. The regional managers will receive the Sales Cloud license for access to opportunities. They'll operate within the regional role. They'll also be above the race coordinators as well. The customer support will receive Sales Service Cloud license for access to cases. Then we have racers that will receive Customer Community license for access to their own records. Charity personnel will receive Customer Community Plus license for access to reporting and sharing. And the adventure trackers users that will be doing the shipping will receive Customer Community Plus license for advanced sharing. The solution is implemented using a single org strategy to consolidate and combine the data processes and collaboration. I didn't see a use for multi-org here, but we will enable multi-language for its global reach, and that will be enabled using custom labels, Visualforce email templates, and Translation Workbench. Translation Workbench will be facilitated by translators that will translate the metadata. Multi-currency will be enabled as well for the global reach here, given the fact that this is rolled out in the United States initially. We'll have the US dollar as the default currency, corporate currency, and then enable multiple currencies later on as well. The Salesforce org here has Chargent installed for the transaction tracking, the payment tracking as well. This will be integrated with DashPay as the DashPay gateway. This will facilitate tokenization of the credit card information so that it isn't stored directly on the platform, and it's only stored in the gateway as well. Digital engagement will enable the chat feature that is a part of the solution. Salesforce Voice will enable the inbound calls that will need to be a part of the solution for the service reps. SDocs will enable the generation of PDFs, and Shield will enable the privacy center that will be the compliance feature for the EU presence. The internal users will authenticate using SAML via Okta. Okta is backed by an Active Directory that is connected with the agent via LDAP. The internal users will also authenticate into the internal app as well using the same method. That internal app is via a auth code plus Pixie flow. External users will authenticate will have two different access paths. They will authenticate using either OIDC, which will return an ID token from Facebook or Twitter, to the auth provider that's set up within Salesforce. That will then be ID token is then validated, and then there's a registration handler to then provision the user within Salesforce. If they choose to use the other alternate route, which is the username password flow, they will be set up directly within Okta as the Okta acting as the identity layer. Okta will then provision them within the external LDAP and also provision them within Salesforce as users. We take an API-led approach to integration using reusable APIs, connecting systems that are managed by an ESB. The ESB also integrates with the public single-page application that I've included in the solution. There's an adventure trackers for the shipping, race registry for the access to the history of races, and tracker database for the RFID progress of the racers as they finish the races. The ETL will facilitate the data migration from the racer databases that are those regional databases that will be decommissioned. I'm going to move on now to the requirements, starting with the race planning and race registration. So during the planning stage, the territory route leaders will create a race record. Those race records are represented in my ERD as opportunity records. They will create them, and they will be representing the idea and the location for the race. The territory route leader will, after they create the race idea, they will route then the different waypoints. Those waypoints are recorded on the mobile app. The mobile app is the Salesforce mobile app that includes an LWC that has a geolocation capability to store the geolocation of where they are. Once they have stored the geolocation, it will then create the record, the waypoint, as an opportunity product that's related to the race itself. The race is not visible by default. It's set to private OWD here, and it's owned by the leader. They will be the only ones able to view it besides their managers that are above them, superior to them in the role hierarchy. When the race occurs, though, that will, and I'll describe this later, so I'll move on from that, and we'll talk about the submission for the idea. So the leader will submit the opportunity that will change the stage to submitted. That stage, as being set to submitted, will trigger an approval flow that will then route the opportunity to the coordinator. That coordinator will secure the permissions to host in the area. And then once they have approved it, that will create then a race record that has the status of draft. That draft that draft status is not visible by default either. It is only visible, the race record is only visible at the point when the status is set to open on the race record that has been created. When it's set to open, the race record will be shared via criteria-based sharing to all, and it will be read-only. There will be validation rule as well to restrict editing to open races for everyone, so that they can't edit the race as soon as it's public, so there's no confusion there. When the territory route leaders need to do historic reporting or analysis on the race data. They can do reporting directly on a aggregated object here called the race summary. I'll go into detail later about how that is created, but they'll be able to do standard reporting as well from a mobile device as well. They are internal users after all, so they have access to standard reports. The racers will be able to access the portal using social sign-on. This will be enabled via OIDC. They will authenticate, and then the social media provider will return an ID token that is validated by the auth provider, and then there will be registration handler for the setup of the user. Very similarly, there will be a registration. If they choose not to use the social media credentials, they can get set up. They'll be routed to the Okta portal. Okta as an identity layer, and Okta they will set up themselves. They'll register using a username and password. Then Okta will provision them directly within Salesforce, and then also communicate downstream into the LDAP the user's user credentials into the LDAP. So the LDAP Okta acts as a Okta routes the credentials for both internal and external based on the access path that they take. So once the racer is created as a person account, this is created as a person account as soon as they register. It'll be created as a person account, which is within my model here. It will integrate with the registry via the ESB. There will be a request reply call out via REST API that will integrate, that will create a corresponding registry record within that system. And then once that registry record is created, the ESB will update the corresponding racer record with the external ID of that registry. Furthermore, there's the migration aspect of it. So there's these existing racer databases that are being decommissioned that will need to be migrating racers into Salesforce. As a part of the migration and as a part of the ETL pipeline, we will ensure that the staged pipeline has the registry IDs as well populated and enriching those racer records before they're migrated into Salesforce. If the Salesforce identifies a duplicate user within this org here, there will be, first of all, it will identify if there's a duplicate user via registration handler. And also, if it does identify a duplicate user, there will be a login initiated that will enable them to begin the password reset process so that it doesn't create a duplicate user for the same actual racer. When the user account is created, they will be able to access the portal, which is this racer portal. They will also use the mobile publisher app as well to search for races, and they will search for races that are set to the status of open. They'll have access to it via those criteria-based sharing rules. The mobile app will enable racers to update their personal information. This will be done using the self-service portal that's within that portal, or they can essentially use the mobile app as well to update their person account. They'll have access to the registrations that they are assigned to based on the fact that they are that is a master detail relationship with the registration and with the person account. And they'll access then the route information via the waypoints that are associated with the race. So once on the race date, there will be a scheduled flow, or actually scheduled apex, that will copy the waypoints that were created initially for the idea onto the waypoint itself so that no one is cheating. So these are just cloned records from the opportunity products here. And that's how they will access then the actual waypoints. The racers will be able to view their racer info in previous races via a ESB integration that exposes OData connectors and exposes then the race history for racers via external objects. So we'll have a race history object as well as race objects for the external data so that they can have access to it, and we're not storing them directly on the platform given the fact that it's already stored and Salesforce doesn't need to store non-operational data. The racer personal data, when it is updated within the mobile app or within the portal, there will be an integration from Salesforce to the registry using fire and forget and change data capture that will be facilitated by the ESB that will update then the registry. The racers will be able to run reports on races that they've run via an LWC that will just have the summarization of the races that they've run. The capacity is set directly on the race by the territory race coordinator. They'll set a maximum capacity. This will be enforced via a record triggered flow on the creation of registration records. So when the registration record is created, it will increment a count on the route on the race itself. And if it exceeds the capacity, then we will update the race status to closed, and there won't be any more registrations enabled for the race itself. Okay. Once the racer has registered for the race, there will be in order to register for the racer will have a screen flow that will create then a registration record. That registration record will have an initial screen where they'll input the level, couch potato, novice, and super athlete. When they submit that, that will then create a charge and order record that will kick off the payment process. The payment process will be enabled through charge and objects that are essentially shadow objects that represent the transactions themselves that integrate then with the DashPay gateway that actually does the processing of the payments. If the charge-in transaction fails from the gateway, then it will notify via retrograde flow the racer. So there will be a object for the status of the charge-in order will be update to failed, and that will then notify the racer via retrograde flow. The tokenized information is stored within Salesforce using these charge-in objects. We're only storing tokenized information. We're not storing the actual credit card information. That's only stored within the payment gateway. The tokenization only references the actual credit card information. DashPay itself is highly leveraged. It's leveraged as a microservice by other, or as a service-oriented architecture, as a coarse-grained service that needs to, that can't be deployed, and it serves other backend systems. So what we're going to do is ensure that we use an API-led approach where we essentially set a boundary between Salesforce deployments and DashPay gateway so that we're not entirely reliant on DashPay for tracking transactions, that we do that separately within Salesforce. Once the registration has been paid for, there'll be a retrograde flow that will update the registration with a unique tracker ID that will be generated from Apex within Salesforce. That will then update that record, the registration record here. That will then email to the racer with the tracker ID. And then once that is generated, Salesforce will integrate with the ESB to store then a mapping of tracker IDs to the RFIDs. So there will be a mapping within the ESB that will temporarily cache tracker IDs to RFIDs for later. The registrations themselves are only, the racers can determine which charity they want to pledge to via lookup on the registration. They'll have that option as well when they when they register, as well as after the fact. If they want to do that later, they can just update the lookup. When the registration is paid for, there is also additional logic here that determines if it's a loyal customer, if they're running a lot and they have 5 different historical races that they've run, this will be enabled a federated query against the external objects here. If they run more than 5 races, then we'll email the racer with a link to opt into the registration premier flag, and that will then have logic to match the pledge amount for the racers that participate in that premier start group as well. So that premier start group will populate onto the registration as a flag and also determine which start group they are assigned to when the race starts. If the racer has questions, they can search a site using knowledge articles. They can search for different materials about the facts and things like that, and these will also be translated via translation workbench. They can also ask questions via chatter, and they can search for races, like I mentioned, via the portal. Okay. The racers, if they have questions or if they needs customer support, they will raise a case. They'll create a case under the registration, and those cases are assigned then to the reps via omnichannel. If they choose to cancel the registration, then the Salesforce will integrate. There's logic around the cancellation to determine what kind of refund they get. Salesforce, in order to determine the type of refund they will get, Salesforce integrates with the Adventure Tracker system to return the shipping status. If it is the shipping status has not been sent out yet, then they will receive a full refund. If not, then they will receive half refund. This will all be determined based on the query that the ESB does for the shipping status. And there will be a chargent refund that is determined based on that. Okay, moving on now to the actual race day. The web page is open to the general public, which creates a stressor for. There's a web page open to the general public for seeing the racer's progress on a map and also creating donations. So one thing identified here is that there's going to be peak loads and queries on racer progress during events. So we'll need to optimize for reads with event projection. This event projection pattern here will optimize for reads by storing the mapping of the racer's progress directly within the ESB keyed to their RFID and their tracker ID, so that the ESB isn't having to query in real time when the guest user refreshes the page. So in order to facilitate this, when the telemetry system, which is that tracker database, publishes an event that is publishing an event, meaning that, say, the racer has passed the waypoint, the tracker will fire an event that is subscribed to by the ESB that maps the ESB itself, mapping the RFID to the progress. This will be using pub sub and event broker models. And so what that ends up creating ESB store is log per RFID of what is the latest progress of the racer. And so when the guest user refreshes the page, the tracker single page application, in this case, a tracker single page application, let me also clarify that. So one thing that I noticed here was that since this is a general public page, we cannot just simply rely on Experience Portal for a general public page. Given the volume of users and the number of refreshes, it's better that we host a single page application that is enabled via CDN. This tracker's single page application is lightweight and will essentially is hosted, for example, on an S3 in an S3 bucket, but is able to integrate with ESB's Experience API using the tracker ID that is submitted within the single page application. That then returns the latest progress using a request and reply and REST API. And that REST API is integrated with the Experience APIs based on the tracker ID. And so that will then output the latest progress of the racer, and that outputs then onto that single page application map view. The map view as well includes a component where they can create a pledge. So when they go into the single page application, they see the racer, they can create a pledge via the ESB. There will also be an Experience API exposed for the creation of the pledge record. That will then redirect them to DashPay for the payment. And then DashPay will handle the payment and return success or failure based on whether or not the payment process successfully. If it's successful, then the pledge record, which is a large data volume object here, will update to the status of success and eventually feed into the charity after the race is completed. If it's failed, then the pledge will trigger an email to the guest based on their email that they submitted when they offered their pledge amount. So we have a large data volume here, and I'll talk about how we're addressing that later. But we'll be aggregating the data itself, the pledge data itself, using first of all the ETL. So the ETL will be needing to migrate pledge data into Salesforce, 5 years of pledge data into Salesforce. That ETL will transform the pledge data into aggregated records, and then also ongoing, the pledge data will need to need to be aggregated as soon as the pledge is completed. So after the race is completed, we'll need to aggregate the pledge data together, summarize it so that it can be stored as well. So that will be essentially moving from hot records to aggregated records to reduce the data volumes and then deleting the pledge records themselves. Okay, moving on now to the race logistics. So when the registration has been paid for, a shipment request is created. So we're stepping back for a second. We talked about the race itself, but now we're back to the shipment of the RFID and the racing bib. So just want to call that out. But when the registration is paid for, we have record flow that the Salesforce will integrate the adventure trackers that will include the runner data, and then the runner data will, based on the runner data, the adventure trackers will generate the RFID that will be stored in Salesforce on the registration record, as well as in the ESB within that store. And then the bib number as well will be stored on the registration. The shipment tracking status will be stored the shipping status system of record is, of course, the tracking system is stored within the adventure tracker system. And Salesforce will do a request and reply on demand with that tracking system via the ESB, so that it gets the latest ship status on demand from the system, and then they can refresh that as well. There will be a scheduled flow 10 days before the race to assign the registered racers to start groups. The start groups will be assigned per race. The batch sizes that are stored on the races themselves, they will also be assigned to start groups based on the premier flag that was assigned earlier. There will be a retriggered flow then to email the racer with the group as well. Okay. We'll use a single page application like I mentioned, and the tracker database will store the latest tracker racer location. That's my assumption in the scenario, since it is a system record for the racer location. It'll be scheduled Apex 1 day after the race to aggregate the pledge amounts, and then to communicate with the DashPay the amount that the charity organization should receive, and then DashPay will process the payment to the charity. The regional managers can edit the charity amounts based on the fact that there is 3 regions. I chose to use criteria-based sharing for the account object to share with the regional manager role per region. And then we'll leverage SDoc to generate PDFs with the total pledge the totals per charity after the day of the race as well. That will then attach a PDF or send a PDF to the charity personnel. And then as a part of that, 1 day after the race, we will also aggregate the pledge data. So after the payment's already been submitted to the charity, we'll aggregate the pledge data and then store the pledge data aggregation per racer race summary on this aggregate object here. Charities themselves are set up via web to lead or email to lead within the system. The leads themselves are created and then approved by the territory race coordinators and then eventually by the regional manager. Regional manager will be the final one to convert the lead to a business account. And then to log in, they will register within Okta using their email. Okta will create a user, provision a user within the external LDAP as well as within Salesforce. Okay. And charities themselves will have delegated administration privilege within Okta as the identity broker that will enable them to set up their own personnel within Salesforce for the purposes for limited read-only views. If charity personnel have questions, they can go through knowledge articles as well, similar to like races, and there will also be translation workbench for the translation of those knowledge articles. There will be sharing sets via the race summary lookup that will enable them to view the donation pledge reports for the charity organization. And the ownership is, It's not sharing sets. It's based on the control by parent, which they'll have access to anyways. So there won't be the need for that exactly. Okay. And then the charities will be able to run monthly and yearly reports for 5 years, which is a significant number of records. So that's why we're aggregating the data to protect the system performance. We're going to aggregate the data on the race summary, and then we'll have a standard reporting via the Customer Community Plus license for these charities. You'll have limited view of the racer details via FL field level security, and they will have the ability to update their information on the account based on their association with this business account. If they need to make other changes, they would simply create a case that's associated with the charity itself, and that record type would be called charity, and then there would be an admin that would handle those for the update of bank routing number or mailing address. If they want to do any ad hoc analysis, they will use standard reporting on the aggregate object. And then there's finally a governance requirement here where there's a history of disorganization, prioritizing the charity funds rather than IT. So, of course, we want to implement a steering committee for a vision for a solution and also Center of Excellence guardrails to ensure that there isn't shadow IT or there's adherence to a common standard protocol for deployments and for development itself. And then, of course, we'll have PMO, CMO that are aligning on the definition of ready stories that fit into the steering committee vision. Moving on now to the final section, which is the customer support, which calls for service reps to be able to take calls, complaints over calls, which will be enabled using Salesforce Voice. Salesforce Voice integrates with Amazon Connect via CTI integration. Those Salesforce Voice calls will be routed then to agents via omnichannel, and then cases will look up then the registration. The case criteria-based sharing there will be criteria-based sharing on the case object that will enable read-only access to the internal support role, to all the internal support reps and agents. Salesforce will integrate with the Adventure Tracker to surface the shipment status. I called that out earlier. The case record, when it's created, will be assigned initially to the territory queue if the case itself is related to specifically a race. It's assigned to the territory queue. That territory queue includes the territory route leader and territory route race coordinator. If the case is created and it is related to the bib or frequency tracker not being received, it should be sent then to the territory race coordinator immediately. This is based on the lookup on the ownership of the race. And the race, once the case is created, they will own that case, and then there will be escalation rules to notify the manager if it hasn't been resolved within 1 business day. And then finally, the digital engagement will enable chat with agents. We'll be migrating data from the multiple different regional racer databases. Those racer databases include the racers, the charity, the pledges, the race history. The ETL pipeline will be responsible for aggregating the data and storing them within the racer race summary object here. The racer race summary object will include the aggregated data, but also as a part of the pipeline, we'll be migrating the racers and the charity. So just to start out here, given the fact that the data itself is distributed across multiple different databases, there is, of course, duplication that has occurred. This will require a data steward that is profiling the data and aligning with the key personnel, the key stakeholders on the source system, which source systems to pull from, the data quality standards, the key field mappings. They will align and then load the data including separately the racers, the charities, into the pipeline that will then be cleansed, deduplicated based on the racer IDs, master data like unique identifiers, including emails, they and tens for in the case of charities. Those will be deduplicated, and then external IDs will be assigned to the records themselves, so there's traceability between the sources and the records that are loaded into the system. We'll order the records themselves from parent to child, so we'll order the racers, the charities first, and then the aggregation of pledges and race history separately will be loaded after that. Then we'll load via bulk API with sharing deferred and automations deactivated. Those will load into Salesforce. Salesforce will run, of course, rehearsal migrations, and then that will culminate in a controlled cutover window for specifically North American records. The North American records will load the person accounts for the racers, the charities as business accounts, the race summary records, and then the races themselves into the system. Those will load into the system. And then there will be, of course, following that smoke test and then UAT sign off. That will then conclude the North American rollout, and then that will be the pilot in 6 months, and then in a year it will follow the same similar process, but with a separate data filtered for the European regional databases. And that concludes my presentation. I'll open for any questions. Thank you.